So our next target is to find the YP. Okay, YP stands for the particular solution. All right, there already we have seen that if you have a differential equation, we can represent that using the following notation, that is d to the n y by dx to the n into an plus an minus 1 times d to the n minus 1 times y over dx power n minus 1, and so on till a1 dy by dx plus some a naught into y equal to okay, let me write the phi of x. Okay, on the right side you can have some function of x, right? So we know that we replace the d by dx as d, a differential operator. Okay, we replace it by that so that you get the an capital D to the n y plus a n minus 1 capital D to the n minus 1 y, and so on a1 capital dy plus a naught into y equal to the phi of x. Okay, so after this we know that we took the y outside to get an d to the n plus an minus 1 d to the n minus 1 plus dot dot dot, this is a1d plus a naught into y equal to phi of x. All right, now so we have this equation with us now. What we do, instead of making the phi of x equal to 0, right, the RHS we made 0 in the previous case when our intention was to find yp. Okay, but now we don't do that because we want phi of x to be present so that we can find that part of y which is nothing but that actually depends upon the phi of x value. All right, now so what we do, we try to keep this. We understood that this whole function we denoted as f of d, a function of d, correct? So what we are trying to do here is we try to move this f of d to the other side. F of d can be anything. So what we do, when the f of d goes to other side, the y will become yp. It's a particular case because depends on the phi of x that is present on the right side. All right, so this implies the particular solution yp is nothing but the phi of x that is present on the RHS of the differential equation divided by the f of t. That is what we get from the above equation, right? So in the sense, I have to keep the phi of x. If you make phi of x as 0 and you try to solve, you get yc, which was our previous case. Okay, now how to solve this? That's the question. So the answer is there are 5 different cases, right? So there are 5 types of yp calculation, and this calculation depends on, right, the phi of x. So 5 different types of phi of x will be discussed, and for each of the phi of x we have different approach to solve. Okay, all right, so let's start with the first one, that is type 1. So type 1 is nothing but the phi of x, whatever phi of x that is present over there, it will be of the following type. It is going to be e to the power ax. In the sense, if you have a differential equation, on the right hand side of the differential equation, I'll see e to the ax. So 4 d square y by dx square plus 3 dy by dx plus 8y is equal to e to the power 4x. So you see that e to the ax will be present on the right hand side of your differential equation. If that is the case, I should understand that this given particular question, right, belongs to type 1. All right, so let's see the solution of the type 1 question. Okay, so what we do here is to find the yp. So yp becomes equal to, I know that yp is equal to what, the phi of x divided by f of d, right? But phi of x in this case, I know that it is e to the ax, right, divided by f of d. So the solution of this particular case is nothing but, it's very simple. Simply replace the d by a. In the sense, in the f of d, replace every d by a. That means it's going to be e to the ax whole divided by f of a itself. Replace every d by a. But so for example, if f of d, let's take an example. Thus f of d could be d square minus 2d, say plus 1. Let's assume the f of d denominator, right? And let's say that the a is e to the power x. E to the x means a is 1, right? What I do, I replace this d square by 1. This is 1 minus 2 plus 1, right? What happened? You see that the denominator becomes equal to 0. But I know that this is mathematically not valid. Denominator, if you divide by 0, actually your answer tends to infinite. Okay, so we have a condition over here that my denominator should not be equal to infinity. So, right, just to demonstrate that condition, I wrote one example, that's all. But we have a solution for even that case. When you see that the denominator is tending to infinite, we have a solution. Okay, but let's write the condition first. Okay, so in this case, right, in such a way that, right, f of a should not be equal to 0 for this case. In this case, f of a is 0 means you know that it's the whole denominator is 0, so I have a problem with that. So if that is a case, right, I'll write here. So if at all the f of a became equal to 0, then this implies I continue the yp. What I do, right, this is actually called as L'Hospital's rule in case of the differentiation, right? So what I do, I multiply this with the whole, whatever you have here, multiply that with x. So x into e to the power ax. So just, right, okay, so that is x into, this is e to the ax. Denominator you differentiate. Instead of f of a, you have to write f dash of e. Okay, so whatever you have, f dash is differentiation of your previous case. Anyway, I'll illustrate this in the example, right? X into e to the ax. But once again, I have a condition that here f dash of a should not be equal to 0. It should not be equal to 0 because once again I have infinite answer coming out. Okay, so in that case, what I do, so if I'll go ahead with the next condition, if at all you find f dash of a becoming equal to 0, this implies yp is equal to, multiply by one more x, already there is a x, this is x square into e to the ax whole divided by f double dash of a. Differentiate this once again to get f double dash. Okay, this will repeat. what happens, you understand that now. So if at all I find f double dash of a equal to 0, what happens now? The next term will be x cube into e to the ax by f triple dash of a, and so on. So I don't write the other answer. So and so on. This will continue until you get a finite answer in the denominator. Okay, there are cases where second, third, fourth, all the derivatives will be 0. After fifth or sixth one, maybe you get the finite answer. This is possible. Okay, so we'll see that in the uh, problems when we solve the problem. So our ultimate idea is that if at all the right hand side I see that, right, there is a y, what you call, e to the ax coming into picture, then I am supposed to solve it using this technique itself. Okay, so simply move it to the denominator and solve. Okay, all right. Now let's go to the problems based on this kind of question. Okay, all right. So problems, that is, so solve 6 times d square y by dx square plus 17 times dy by dx plus 12y is equal to e to the power minus x. So you see that on the RHS it is not 0 now. This is e to the power minus x. I see that, okay, this question, it's a differential equation, RHS is e to the minus x. I understand that, okay, this belongs to type 1 of the problem. Okay, so my approach is first to find yp. To find yp. Okay, what do you do to find yp, right? Equate the RHS to 0. Recall the previous classes, right? I have to make the RHS equal to 0. Then I have to solve. Okay, so this means it is 6, right? Uh, so you understand the conversion now. So I have to replace every d by dx as capital D. So let's skip one step, right? Directly I'll write, to find yp, I'll write the d by dx as d, the operator. So which means it is 6d square y plus 17 capital dy plus 12 into y equal to 0. So do this and make phi of x equal to 0. So RHS should be made 0. That's what I am writing here. So once you do this, you get this answer. Now what you do, you take the y out. So that is 6d square plus 17d in, sorry, y is not going to come. 17d plus 12, multiply this with y equal to 0. So I know that to a product equal to 0 means I have to write an auxiliary equation. So auxiliary equation is nothing but replace d by some variable, say m. So this is 6m square plus 17m plus 12 equal to 0. Since y cannot be equal to 0, I know that y is not equal to 0. This means I have to equate the auxiliary equation to 0. Okay, so now again I have multiple solutions possible, multiple ways you can solve. You can use a calculator, but I will go with the factorization itself. That's easiest here. So this is 6m square, 17 means I can do 9m plus 8m plus 12 equal to 0. Sorry. So that means let me take a 3m outside here. When I take 3m, this becomes 2m plus 3. So here, if you want a 2m inside, I should take 4 outside. So this is once again 2m. 4 into 3 is 12. So 2m plus 3 equal to 0. So now I can see that the 2m plus 3 is common over here. That's why this is 2m plus 3 multiplied by whatever is remaining inside, that is 3m plus 4 equal to 0. Alright, so because of this answer, now I can equate either 2m plus 3 to be equal to 0, or the other option should be 3m plus 4 equal to 0. So this implies 2m equal to minus 3. So m should be equal to minus 3 by 2. This is one answer. Okay, similarly, I can write 3m equal to minus 4. So m is equal to minus 4 by 3. This is the other answer. So now I understood that the two values of m for this given problem is nothing but minus 3 by 2 and this is minus 4 by 3. Right. So my intention is to calculate YC. So I have to refer back to the table which we had written earlier. And from the table, I understand that this m equal to minus 3 by 2 and m equal to minus 4 by 3 belongs to first case, right? The roots are real and distinct. So whenever the roots are real and distinct, right, we know that the guess of YC should be in the following format, right? That is a constant into e to the power first root, that is minus 3 by 2 x, plus another constant c2 into e to the power second root minus 4 by 3x. So this, let's hold on to this answer now. Okay, this is my YC for this particular problem. Okay, till here we are fine because we already have solved this. Now, let's go to the finding of YP, right? To find YP. What is, in order to find YP, I will directly write the answer, that is YP is equal to the phi of x divided by f of d. I look at my question and in the question I can say that, right, the phi of x is here, that is e to the x, e to the minus x. I understand that. So I replace, sorry, yeah. Okay, so e to the phi of x is e to the minus x divided by, from where I get the f of d. F of d is nothing but this part. Okay, this is the f of d. 6d square plus, okay, so f of d in this problem is going to be 6d square plus 17d plus 12. Right, now from the basics, right, in the sense what we discussed today, it says that how do you solve? The solution of type 1 problem is nothing but replace the every d by a. Observe what is a in the given problem and replace every d by a itself. So let's do that. So when I do that replacement, I'm going to get this. Okay, so my solution is replace every d by a. So what is a? A is actually e to the ax. When I look at the question, it is e to the power minus 1 into x. So every d should be replaced by minus 1. Okay, so this means it is e to the minus x divided by 6 into minus 1 square plus 17 into minus 1 plus 12. Okay, so this means this is equal to e to the minus x divided by 6 into minus 1 square is 6 itself, minus 17 plus 12. So denominator is 6 plus 12 is 18, 18 minus 17 is 1. So this means the yp for this given problem is simply e to the minus x divided by 1. So that's the answer. So I got yp. Okay, now the final answer. Therefore, the solution y is equal to yc plus yp. So yc we already have calculated. So I think we got c1 e to the power minus 3 by 2x plus another constant c2 e to the minus, I think, 4 by 3x, and this yp is e to the power minus x. So we got an answer which contains only x terms, no dy by dx, no y. So that is the solution of the given differential equation. Okay, it's a very straightforward question. We can solve it, right, using this technique. Okay, now let's go to a different question. Okay, next question, question number 2 for type 1. So the question is y double dash plus 2y dash plus y should be equal to cos hyperbolic of x by 2. Alright, so this, we know that y double dash is nothing but d square y by dx square plus 2 y dash is nothing but dy by dx. Okay, plus y is equal to cos hyperbolic x by 2. So this means what? I know the standard procedure. First, let me find the yc. Okay, to find yc. Anyway, to find yc, I don't want the RHS. I can actually make this 0. So irrespective of what is present on the right hand side, right, I have to make sure that I make that equal to 0. Okay, so what's my procedure? Make d by dx, replace that by capital D, and make the phi of x which is present on the right side equate to 0. So when you do that, I get d square y plus 2 capital D times y plus y equal to 0. So in the next step, I am supposed to take y outside. So d square plus 2d plus 1, this is the f of d, into y equal to 0. So this will be my f of d. I'm going to use this in the calculation of yp later. Okay, all right. Now what I do, I write the auxiliary equation AE. So that means it is replace d by m square plus 2m plus 1 equal to 0. Okay, so this means, right, it's a perfect square if you observe. So I have m plus 1 into m plus 1. These are the factors equal to 0. When that is the case, right, I understand that m is equal to minus 1 comma minus 1. These are the two roots. Okay, I refer back to the table, and when I look at the table, I understand that it's a real and repeated root, right? So when you have real and repeated, the case number 2, second case, it should be very clear now. So yc should be guessed as a constant c0 plus c1x, two terms because there are two repeated roots, into e to the power minus x. Very straightforward. Let's hold on to this, right? Because I'm going to use this yc plus the yp which we calculate in the next step to get my final answer. So that's why we hold on to this. This is the yc part. So to find yp, I need this f of d. That's all. I just have to remember this. Okay, now, so let's go further. So in the next step, my intention is to find yp. Okay, so standard procedure to find yp, what's your equation? Equation is yp is equal to, look at the f of x given in the problem, sorry, phi of x given in the problem, divide by the f of d. Okay, now, so yp is equal to, let me write the phi of x given in this problem. If you look at this, it is cos hyperbolic x by 2 whole divided by f of d. Okay, now if you look at this particular part, I will not understand that why this is in type 1, because type 1 was expecting e to the power something, but there is no e to the power here. It's a cosine hyperbolic function. Okay, but right, the tricky part is that you can use a trigonometric identity to convert cos hyperbolic into e to the power. Okay, so that's why we included cos hyperbolic under the case number 1 itself. That is okay, let me write cos h theta. Cos hyperbolic theta is nothing but e to the power theta, okay, plus e to the minus theta whole divided by 2. So this is the equation. So you can see that if you have cos h of theta, so what is the theta in this problem? In this problem, theta is x by 2. Okay, so cos h of theta is e to the theta, e to the minus theta by 2. If you do that, you are going to get your answer. You can convert the hyperbolic cosine function into an exponential function using this. We know that exponential functions are covered under type 1 of the problem. That's why cos h is included here. Okay, so let's do this. So this is equal to, so I substitute cos h by 2. So cos h of x by 2 is nothing but e to the power whatever is inside the bracket, right? So that means e to the power theta is x by 2, e to the x by 2 plus e to the minus x by 2 whole divided by, there is a 2, so this is 2 into f of d. This is my problem now. Okay, what I do, I further substitute. This is equal to, right, e to the x by 2, right, plus e to the minus x by 2 divided by 2 times, I look at f of d. In this particular problem, f of d was d square plus 2d plus 1. Okay, now, so I'm supposed to make a substitution, but before that, let me elaborate. So half I'll take outside, and for e to the x by 2 only, I'll write first I'll write the denominator d square plus 2d plus 1 plus the second term is e to the minus x by 2 whole divided by, this is d square plus 2d plus 1. So it's same as the previous step. Now you can make a substitution that, okay, sorry, not outside, because I have to do it inside the bracket. The reason is that the first term has a different e to the power ax. So a is half here. So replace d by plus half. For the second half, it is replace d by minus half. Okay, because you see that there is a minus sign here. Okay, that's why I cannot use the same term for both of them. So now what we do, let us substitute this further. So this is equal to half, I'll keep it outside. Numerator is e to the x by 2. This is d square is half square plus 2 into half plus 1, because I'm substituting d as plus half. Alright, the next term should be plus e to the minus x by 2 whole divided by, now the denominator d should be replaced as minus half. So minus half square plus 2 into minus half plus 1. Okay, see the change. First term I'm replacing the denominator d by plus half. Second term I'm replacing the d by minus half. Okay, strictly following the rules. Okay, now this is equal to half e to the x by 2 divided by, let's calculate. So this is half square, 1 by 4 plus 1 plus 1. So this is 9 by 4. Okay, plus e to the minus x by 2 whole divided by, okay, minus half whole square is plus 1 by 4. This is cancelled, so this is just 1 by 4. All right, so just to expand this becomes equal to, so I can actually cancel the 2 with the 4. This becomes 2 by 9. First term is 2 by 9 e to the x by 2 plus the 4 goes to the numerator and cancels with the 2. So this is simply 2 into e to the power minus of x by 2. So you see this is yp. Alright, so we come to the final part of our answer, that is therefore y is equal to yc plus yp is my final solution. So let's write that. So we got the yc like this. Yc was some constant plus constant into e to the constant into x, my mistake, constant into x e to the minus x. You can see that this is coming from the one which we have, equation number 1. Okay, and let me call this as equation 2. So 1 and 2 I'm clubbing together to get this plus the equation 2 gives me yp, so that is 2 by 9 e to the x by 2 plus 2 e to the minus of x by 2. This is the final answer for y. So you